good afternoon, everyone. Thank you for joining our session, and let's get this going. So I want to start with a real simple analogy: your car engine light. So for me, when it goes on, it's like your first reaction is, okay, what's going on? What caused this, and when do I need to do something about it? If you think about an industrial environment, they have potentially on a well-run plant, potentially has hundreds of these kind of lights going on, and they're in the form of process and diagnostic alarms. And these process and diagnostic alarms, if you don't have context, could be could be a precursor to a downtime, an unplanned downtime event, and that can be a very expensive proposition. So it's this uncertainty that we're going to talk about today with our presentation. So how can AI agents with existing systems you have today be used to address that uncertainty? So I'm Paul Vendetti, I'm from SAS, and Caleb's from Factory XT, and we're going to walk you through a real-world example solution for a paper machine with motors that keep it running. So we basically have organized this presentation into these following areas. So I'm going to spend a little bit of time explaining the paper machine use case, the problem we're looking to address, and then we're going to toggle back and forth between me and Caleb. Caleb's going to talk about the real systems that exist and what is kind of the typical state of the art of the operational technology that exists around this paper machine scenario. And then I'll pick up with some of the traditional AI approaches, and then we're going to get into the agentic stuff. We have a solution called Retrieval Agent Manager, and we're going to show how it coordinates with this operational technology system. Then I'll hand it back to Caleb so that at the end you can start to see how does this all come together for the people we're working through for this application. And then we'll conclude with a summary and how you can get started, how we think you can get started with this. So I know we have a subject matter expert in the room, so I'm not going to attempt to explain paper machine methodology, but at a high level, we've got the diluted slurry and the wood fibers being placed from the wet end of a paper machine onto this wire mesh, moving very rapidly through sections of this paper machine where it's pressed and dried and then wound into final product. And there's many motors with this application, and we've actually created synthetic data using another technology we have that Steve Ank in the room has presented in a separate session. So we've generated synthetic data around this. We've actually pulled actual manuals for the motors that are typical in this application. So we have 19 motors as part of this use case. So what does an unplanned downtime look like? So when a motor fails, you either have the wet mess or the dry mess, depending upon where the problem happens. So wet mess, again, pulp overflows. You have a big wet mess, and then obviously you have to shut down, clean up, and restart. And this is not a simple process, as I'm sure our subject matter expert in the room can attest to. And it's very expensive. And again, on the other side, same scenario. And not in addition to the unplanned downtime, it's also a safety thing. So obviously you've got this environment where it's now dangerous to some sense to deal with cleaning this up as well. So you have both the unplanned downtime and the risk that goes with this. So the unplanned downtime, obviously this has got a high cost for lost production, potential safety. And there's other challenges. The other challenges are, okay, we have data. So it's obviously more than the check engine, like the diagnostic alarms. There's a lot of data that does exist. But is it being analyzed? So the opportunity to analyze this data is important. The skills gap crisis. So that's something we did a survey for AIoT, and we found that that's a top item, preventing adoption in this area. And there's a lot of reasons for that, but the evolving technologies, the convergence of operational technologies with data science, with AI, and now agentic AI is creating kind of a skills gap challenge. And then the other thing is the legacy system integrations. There's SCADA systems, CMMS systems, AI solutions. If you build better systems in isolation, but you don't really coordinate across it, that certainly has an impact on what we're trying to achieve overall. So those are some of the challenges. And what's our goal? So the goal is really zero unplanned downtime. It's our North Star. So that's the objective. And also with this technology, our goal is actionable insights from complex sensor data. So being able to fuse together, unite IoT data with maintenance data, with models, to really help there be data-driven decisions from the workers. So regardless of the worker's skill set, whether they're experienced or not experienced, you want consistency in how you're presenting that information to them so that it's again, trusted and explainable. A maintenance tech isn't going to change out a motor because the AI system told him to change out the motor. He needs to have trust, so it has to be, again, you have to, again, have that explainability and traceability to how it came up with that answer. So we're talking about two different personas for what we've been working on here. They're very different users, and they need different things from the AI system. So one is the technician, and one is the maintenance planner. So the technician, again, is someone we call in the loop. So like I said, you're kind of building up your AI agent, and you're proposing your recommendation to the agent, to the technician. And so the technician then needs to understand that and make the decision about making, using that recommendation and what he follows relative to work tasks. That's human in the loop. So the person's going to make the decision. Now, if you can imagine, there's lots of these things happening, lots of movement of maybe ordering parts, scheduling things. Some might be critical, and it might need to be all more automated. That's where maybe the maintenance planner might have more of an interest in having some of the logistics for how this is scheduled, with available windows, with these critical assets that can be somewhat automated, so that the maintenance planner doesn't have to go through the drudgery of going through all these different systems to create these plans. That's, again, potentially on the loop. Now, they still have final say. They can override what the agent system, but they are, again, given the automation, they're seeing the opportunity, and they make a choice. So two different personas, two different objectives, and we'll talk about that during the story. So context. So we talk about IoT. I'm not talking about one type of sensor. In applications, there's many types of IoT sensors. And so in industry, these are the big five that we generally see. Vibration is predominantly one of the top ones. But there's also with motors, motor current signature analysis and oil analysis. These are the technologies that help you understand the failure modes that are prevalent. Any failure mode can take out your asset and be the precursor to an unplanned event. So it's important to be mindful that is your sensing and is your AI capable of tracking to the types of things that cause downtime. So if you look at motors and their and the reliability rates, bearing, vibration sensors are really good at catching bearing in certain failure modes. Motor current sensing more on the electrical side as a general rule. And temperature is another important item as well for, again, catching both bearing and winding issues. So it's a layered defense strategy. So again, understanding what you have is also important, because that also builds confidence in the results and the answers. So if you don't have certain sensing technologies, that should also be accounted for, in a solution. So I've kind of defined the problem in the application, and now what I'm going to do is turn it over to Caleb, who's going to pick up from there and show you kind of the traditional approach to this.
Thanks, Paul. So what I want to do right now is I want to set the foundation for what we're currently doing. So you can see on the left-hand side, we have our paper machine, and on that paper machine, we have our motor, and it's generating volumes of condition data, things like temperature, vibration, and current. And what we can do is we can send that data over to FactoryTalk Optics, our SCADA system. And what this enables is local processing of that data on the edge. It enables us to move that data into other systems. Not only that, it also allows us to do things like real-time monitoring of that data. And we can generate alarms and events and convert those raw data signals into something that's actually meaningful. So let's say that temperature value, or the temperature gets a little too hot for this motor. We can have thresholds that will trigger these alarms. And then we can send these alarms as events into our CMMS system. In this case, we use Fix. And Fix is a maintenance management solution. And this signal will do things like automatically trigger work orders and assign a technician to go and inspect what is happening with this motor, because the temperature is too hot, something's wrong. And so it's the combination of these two critical data sets that allows us not to just see what's happening right now, but also what's happened historically with this motor. And so now I want to dig into just a functional flow so you get a better picture of where that data is flowing, where it's coming from, and where it's going, right? So this is the full picture. On the very left-hand side, we start with the OT layer, this is our motor, again, with all of that data. And we can send that data via communications protocol into FactoryTalk Optics, our local edge runtime. And on that same exact system, we can also optionally have a SAS event stream processing running so that we can further filter, enrich, and act on that data in real time. And then back to optics, that data can then be made available to our cloud and IT systems, things like SAS Viya and Fix. And so the key idea here is really simple. We're taking our data from the edge and we're bringing it into the systems where decisions are actually being made. And so what I first want to show you is a demo of FactoryTalk Optics, what a simple screen looks like. And you'll see that we are monitoring a dryer motor on this screen. You can see the status is normal, and we have the temperature and vibration and current signals. As some time passes, these signals, this data kind of starts to get out of whack, and we can see the alarms begin to populate in the bottom table. We have that big red bell screaming at us, something's wrong, and you can see that the asset status turned to critical. And so that's our meaningful event, and then we move into our CMMS system, Fix. And so this is Fix CMMS, and you can see here we're digging through the asset hierarchy, getting to our dryer motor that's represented digitally here. And you have a bunch of metadata, and we're clicking into the meter readings and events. And you can see here that the temperatures, vibrations, and currents are being streamed directly into the CMMS. Not only that, but we have our events, too, that are being populated from the alarms. So we have a high temperature, critically high temperature. And this is telling us that a preventative maintenance has triggered the generation of a work order. And this work order gives us detailed instructions to go inspect, and then also to assign a technician to go inspect it and do those things. So we're moving from insight to action, and that is, or from raw data signals to action. And that is the real foundation that we have currently. We have real-time condition data from the edge, and we're combining that with structured maintenance history in the CMMS. And by doing so, we're enabling us to see what's happening to this asset over time. And also, the volume and the robustness of this data is what allows us to do things like assess asset criticality. How likely is this going to fail? And we can do further modeling and optimization. And from there, I'm going to pass it back over to Paul.
Thanks, Caleb. So as Caleb said, now we have two key ingredients for, this is kind of like a dream come true for an AI company. You're giving me sensor data and you're giving me event history data, and you're going to have context to that information. So now that alarm or that condition has all that additional metadata. And so that's, again, where we can start doing things like reliability modeling, which starts getting at the check engine light problem, which is how long do I have? So now you start, again, being able to use these specific data, you'd be able to use these specific data elements from the CMMS system, which is kind of what we need to run some of our reliability techniques. And again, even if the customer doesn't have failure modes built out, there's still methods we can methods we can apply from SAS to start even getting some insights on which ones are descriptively having events at different points in time, comparing the wet end of the machine versus the dry end. That metadata is very rich relative to being able to look at the population of motors based on other data that's existing in the system. But ultimately, if you can build the the lifing models, we can again start to put that survival probability that runs as a model to start telling you, can you make it to your next outage? That's, again, it's not a given certainty, but it's giving you some of that evidence that you need to make a decision. So now we kind of, so traditional AI is, the point of that is there's traditional AI methods that are really valuable when we start moving into an agentic area. So with SAS Retrieval Agent Manager, there's two capabilities we're going to talk about. One is what I call RAG LLM, that's retrieval-augmented generation with an LLM capability. This is, again, where we can take advantage of the other content that's maybe not being utilized, which is the documentation that sits in the Fix system. And that documentation, when put into the Retrieval Manager, we're able to orchestrate the RAG pipeline. So now, in our demo example, we have various manuals. These are actual manuals we pulled from the Baldor website. So I have, for our spec'd motors, I pulled out the Baldor operation manuals, maintenance manuals, troubleshooting manuals, product spec sheets, and for good measure, I threw in some industry troubleshooting for motors too. So we, again, tried to make this realistic. And again, in using SAS Retrieval Agent Manager, we have the ability to establish this RAG pipeline with this is a user interface that, a non-programmer can use. So basically being able to take some of these complex ideas and just orchestrate the RAG pipeline. And what I'm going to do is show you that now. So basically within the tool interface, it starts with identifying sources. You can upload them locally. You may have a repository of content. The point is we ingest those documents. And those documents, again, are then loaded into the system. They're organized into collections. Why? Because it makes sense if I'm troubleshooting or doing something else, I might want to organize these documents into a collection. So here you see an operation manual. And the two things you see here are RAG pipelines I've executed. And when I execute a RAG pipeline, it does some very cool things relative to evaluation. It creates automated prompts based on the content and gives me a kind of a quality score based on something called RAGAS, which is, again, kind of precision recall on the accuracy. Then you also, again, set up your vector database, your embedding model, and then you can test it out. So it generates an evaluation score, but then you can create these retrieval settings, meaning I can specify different prompt strategies, select those collections, select my LLM, and I can put a question in. So in this case, you're going to see a question, why did a very specific motor pull more amps than the nameplate rating? It might actually be an alarm system, but I'm just trying to show the idea here. So you got your prompt. It comes in with possible causes and recommendations, and it's done with a concise prompt, which is what I requested. Now, the other advantage of this is I can do the traceability. So within our system, I can see where did it pull from, like what document did it pull from, and you can also see the chunking that goes with the document. So the RAG pipeline with a chat capability is, again, demonstrated in this area. But that's, again, shows you how we get that part of the story done. But there's more. So to get the agentic space, what we can do is think through the tools and technologies that are available to help that technician persona. So I want to leverage the metadata of the motors. I want to leverage an FMEA. What's an FMEA? It's a failure modes effects analysis. It's a way to take all the types of failure modes, and engineering teams typically do this, all the failure modes, what's the effects of the failure modes, and how do I recover, how do I return, and do I have detection methods on it? If you don't have detection methods on it, like we talked earlier, if you don't have certain sensing, your risk score is going to be higher because you're not sure. So an FMEA is a tool that could be incorporated into this flow. And then obviously we can run work order history and pull out the manual. So now you can see that I can get information on the asset, I can do a diagnostic failure analysis, I can pull up contextual information from the manuals as I showed in the previous video, and I can run a history check. And what I want the output of the LM to be is a diagnostics, step-by-step instructions, and I want you to verify for me when it's implemented correctly. So I don't want you to read this because I'm going to show it to you in a minute, but basically it's organized response that's very specific for what we're tending to provide to this persona. So same interface. So now I'm going to show you how I did set that up. So I set up a very specific agent called the motor technician, and everything you saw in that prompt visual I created is written right here. So now it's telling them exactly what I want the agent to do. And then for that agent, I go in and I set up a strategy for that agent where I can spell out what LLM I want it to use, how much memory to allocate to this. And again, I'm using that specific agent. I can also incorporate tools. So if I've built special models and tools, I could incorporate that. And these are the collections I want it to use. So again, I'm telling it what to use. Now, the same question I asked, but I just immediately go to the agent. And the agent now, you'll see the response is quite different. It's basically structured based on what I requested. So again, prompts and how you do it really needs to be tied to the workflow, but I hope we illustrated this, that there's a way to, again, leverage the different tools and data to accomplish this. So then, again, the next part of this is the MCP server part of the Retrieval Agent Manager. This, again, the whole RAG is just one tool with some of the collections in there. This can be broadened out. So if you have additional models that are stored somewhere and you want to integrate in with the different databases and data stores, the MCP server can orchestrate. MCP is kind of the ability to orchestrate across more of your enterprise. that offers you a lot more capability. And while I showed you the one, I'm not going to go through the second scenario. I showed you the maintenance agent. I similarly can do the planner. So the planner now is using different tools. I want a criticality analysis. I want a financial analysis. I want a reliability model to give me the insights before I make a maintenance decision. So this is done differently relative to what I want for that planner. So one alert, two workflows. So again, you're able to, again, orchestrate different things based on who the users are. So that's, again, that. And so what I'm going to do now is turn it back over to Caleb, who's going to kind of show you how this all comes together from the operational side.
Yeah, so you can see here, this is our finished overall business architecture with the agentic UI in the bottom right here. And the agentic UI lives on top of all of our data sources that we have. So Paul just demonstrated how intelligence is generated. The agentic UI is how that intelligence is displayed back to the end user. And so I'm going to put a hold on showing the agentic UI, and I'm actually going to dig back into the MCP server because some of the work that I did is I used the MCP server to connect directly to our CMMS system via the API and show you some of the queries and insights we were able to get. And so at a very basic level, I was able to query and just ask, hey, give me some work orders for this asset. In this case, it's our dryer motor that we were looking at earlier. And what it does is it gives us a full list of asset context with the different work orders, selection of work orders from 36 total, it's telling us. And it's giving us short descriptions along with the recent asset events, the things that have been occurring in the SCADA system from that real-time data. And so that's a very basic thing that we can do, but we can go further and we can ask it things like, what issues has this asset had? So now we're getting into an area where we're seeing how this asset's behaving over time, and we're grouping these issues into patterns. And we're seeing that we have multiple instances cited with work orders of high temperatures, high currents, and critical vibration. And so no longer, if we're looking through the system, are these isolated events. They're all brought together. And so we can see now in inference that this motor is problematic. It's giving us a lot of trouble. And so kind of back to Paul's car analogy, sometimes this could be used as a justification for replacing this motor. We've put in more maintenance than what we think this motor is actually worth now, so we're just going to go ahead and replace it. And I've had a similar experience. I had my grandma's 2004 Chevy Impala that was breaking down on me every other week, and oh my gosh, I think I got towed 3 times over 2 weeks. It was this whole thing. And so I bought a new car. Thanks, Mark, for helping me out with that. So yes, we can begin to unearth patterns, which is very, very powerful. And then finally, too, this is where we're moving from insight into action. We can ask for an asset health assessment for this dryer motor. And you can see it's giving us a likely root cause based off of the maintenance work order history. And so it's telling us that the technicians have noted that there's chronic bearing wear and or misalignment that's possibly worsened by the environment, or there's some form of overloading. But we don't just stop at the diagnosis. We actually move steps further into recommended next actions, which is something that, if you're a new technician, you don't even know where to start. You receive the work order notification, it tells you to go inspect, but you don't know what to expect or what to even look at to fix. So the recommended next actions, extremely powerful in how we're moving from the different layers of data sources into making a decision. And so finally, this is our agentic UI. This is where everything comes together into one place. All of the different data sources, the CMMS, the real-time data from the SCADA system, the SAS, the agent insights are brought together into one single interface, the agentic user interface. And so what this is doing is it's simplifying the complexities of all of these data sources. So instead of having to go to each one individually and kind of stitch together information, we have everything available to us right here in one place. So we can get recommended next actions. We can begin to prioritize where we need to focus our maintenance efforts. And so this is how the end user would operate with that. And so this isn't just another tool. What we're doing is we're, again, simplifying that decision-making process. And by doing that, that's how you go and you get faster decisions, and you have better outcomes and ultimately less downtime. And so with that, you might be wondering, how do I get started? And Paul is going to wrap up with that.
Sure. Thanks, Caleb. So obviously there's different parts of the journey. So basically we think that one of the initial parts is kind of evaluating, take inventory of what your existing capabilities are, what is your data infrastructure, where are you at in the analytic maturity life cycle, and taking advantage of the data is really the first starting point. So we don't just say, let's just jump to agentic AI, even though a lot of people are interested in what we can do in agentic AI, and we show them, but we really want to build a foundation. We think the differentiation comes in being able to build traditional AI methods as a starting point. That only, as I hope you saw, makes these agentic capabilities more accurate, more trusted, more capable. So, and obviously integrating in with the operational technologies is also very critical here. So the modeling, the working to make the cross-system context relevant is step one. And then obviously we tap into data sources that aren't being used. So like the documents is obviously an obvious one. There's lots of wealth of knowledge inside documents, and that's a good starting point because that's usually a company's internal source for its specific assets. So there's a great opportunity to start there and get that enabled in this process, which I specifically showed. And then obviously the agentic stuff is where we can just continue to layer more and more capabilities with workflows tied again to the business process and the users. I think it's critical that the users understand what the systems are doing and get their buy-in moving forward. And that's kind of the summary is, again, being able to get at, speed is at the end of the day. It's faster issue resolution, lots of clear context, ultimately moving towards our North Star of no unplanned downtime, and obviously addressing this, at least in our process, we think alarm management is a big issue, and we hear that frequently. So how can we make sure that any of the indications that are coming from machines and processes has some assessment on it, so that again we improve the organization's ability to respond to things when they're being notified. And that's the end of our talk. So we'd be glad to take any questions.
On the application that you showed at the end, are those API calls to the agents that you created and then showing on like on a self-hosted web application, or how exactly does that data go from your SAS environment into what you developed?
Yeah, that's typically how it would look, is those via the API calls. The template already exists for the UI, and then the model would just populate that template with those insights from the different data sources, because it's living on top of everything that you have. So yeah.
Are you building some type of knowledge graph that's correlating the data between your CMMS and the HMI and the manuals that are referencing those?
That's a great question. We have a solution that would do that. It's a data operations platform, which would be separate from these two systems. But Fix is relationally linked in terms of its database, and so that graph kind of exists already. But in terms of, well, actually too, in optics, there's like an object-oriented style of approach where you create smart objects that represent your assets too. And that's how you link up those. So it exists, but not in a very formal way. You would have to, to have that automatically built out, use some other tool, but.
Okay. If we don't have any other questions, we're good. Okay. Please.
Thank you, guys.
Thank you.